Okay, 1 o'clock. I think we might kick off. Hope everyone enjoyed their lunch. Didn't eat too much and you're not going to fall asleep during this session, I hope. But so my name's Adam Murray. My Twitter handle is Muzzer78. I run a small consulting company in Sydney. So we do a lot of work around Azure. We write some software. So do a lot of stuff with PowerShell around automation. Today, we're going to be looking at using Azure DevOps. So when I originally posted this session, it was VSTS. But as all things technology, nothing stays the same very long. And it was rebranded about a month or two ago. So don't forget it is HackerFest for October. If you make a pull request to a Microsoft repo, you'll get you can get a T-shirt, I think. So the problem that I'm going to cover today is, as we got more into our module development and we started doing more advanced things, we found that we started having use cases where we'd have maybe DLLs as part of our module, and we didn't want to be clogging up our Git repository with those binary components. So what we looked at doing was essentially having a build process so that we could separate our binary components away from our actual code. So we went down the path. We used Azure DevOps, which was formerly known as VSTS, to create a build pipeline. And we used a feature within VSTS called package management. So package management gives you a NuGet repository. You can actually have different types of repositories. So you can have NuGet, NPM. They've just released a universal provider, so you can store actually any type of artifact. You could just zip it up and put it up in VSTS. So that just came out very recently. So we're going to create the project. We're going to go through the whole life cycle of creating the module, how to deal with the binary bits, doing the updates. It's pretty much a full demo session. It'll take up most of the time walking through the demo. So using NuGet is actually just a zip. It's a zip format, so you can actually rename a NuGet package to .zip, and you can just look at the contents of it. The PowerShell gallery actually runs on NuGet as well, which leads to this interesting idea that since Azure DevOps supports NuGet repositories, I can then create a repository that I can use as my own private PowerShell gallery. I use Plaster to scaffold my module. So Plaster's it's a templating system, so you can essentially set up how you want your folder structures to look like, what sort of replacement that you want to happen in your files as the module's being created. I use Invoke Build to actually do most of the build steps. So there's two main modules that I've seen for doing builds. It's psaki and Invoke Build. They're quite similar. One of my drivers for using Invoke Build was that's what, for the PowerShell extension, I think David Wilson at the time was looking at it. Rightio. Then we'll create the build pipeline using the YAML features within Azure DevOps, and I'll do a demo of doing the actual updates as well. Who's used VSTS or Azure DevOps in the past? Okay, that's good, quite a few people. Microsoft's put a lot of effort into actually improving this, and it really does cater for the full software development lifecycle now. So all the way from doing your code management to doing your build, your release, and your work management is all catered for. So we're going to got an empty Azure DevOps account here. So the first thing we're going to do is actually create a project. So we'll just call it psconf. We're going to do a private project, and we can just stick with all the defaults. So this just takes a minute. And then down here on the left-hand side, we can see the different types of features that I have within Azure DevOps. Microsoft's actually split these out as part of the rebranding so that you can use one or as many of these services that you want. You can actually enable them or disable them. For our purposes, we'll just leave them all enabled. What I've got out of the box, once I've created a new project, I get a Git repository, and we're going to use that for our code base. I have the pipelines, so this is where I can do my builds and my release pipelines. And we're going to be using artifacts, which was formerly known as package management. So because our module's got binary bits and also our PowerShell code, we want to create two different package managements. We're going to have one for the binary pieces and then one for the module itself. So we'll just start off by creating a couple of those feeds. So we'll call this one psconf bin for binary. There's a couple of settings. You can actually use upstream sources. So nuget.org, if you wanted your repository to be actually able to cache packages from nuget.org, you can have the feed set up to do that. For us, we don't need it, so I'm just going to disable it. Okay, we'll create another one for the module itself. So now we've got our two feeds that we're going to use as part of our build process. So now we need to look at how do we get our NuGet package up into this artifact repository. So Azure DevOps gives you a lot of help on how to do that, which makes it good. So when you've got the new feed, you just select connect to new feed, and you get all the commands that you need to run. So we actually have to register the feed with NuGet because we're going to be pushing our NuGet that contains our DLL for our project. So we'll just do that now. Okay. Now I've got a NuGet package I've already created, but I'll just show you inside the NuGet package. Essentially, under the lib folder, you can have all your artifacts. So you could have DLLs, executables, whatever binary component that you need as part of your module. To create the NuGet, the actual NuGet package, you can use the nuget.exe, and it can scaffold essentially a XML file that is used when you create the NuGet package. There's plenty of documentation online about creating NuGet packages, so we won't spend any time on that. So we're going to do a push. So this search that I'm using, if anyone hasn't used it, this is PS Readline that came standard with Windows 10. That gives me the functionality to be able to search back through my history. It gives you all the color coding. So it's actually providing a very much rich user experience when you're on the console. So one of the things to note here is when you're pushing to a VSTS repository, it requires the API key to be set as VSTS. This is probably going to change with Azure DevOps. So I haven't actually checked since they switched over, but VSTS still works. So we can see our package was pushed. So we go back to our repository. And I'll just refresh. And I can see my NuGet package is now available. You can have multiple versions against a package as well. So if you make a change, you can update that package, and you just push up the new version, and that'll be tracked within the artifacts. Okay. So now we're ready. We've got our binary bits sitting up in Azure DevOps. So now we want to create our module and create a build process that will then pull those bits in during the build process and publish and actually publish our module. So with Plaster, it's simply invoke Plaster. We've created a template called Tickaboo PS module template, and I'm just saying create the module in the folder new repo. So this goes through a series of commands. So we're just going to call the module psconf. The default version number. We're going to use Visual Studio Code. So the reason I specify this in my template is because I can add my VS Code settings files into my module as part of my scaffold. So using those, you can have things like if your team wants to have trailing white spaces trimmed, you can have that setting enabled. That's one example. We're going to use Visual Studio Team Services for our build, or Azure DevOps. Our module does include binaries. And then I need to specify the name of the repositories that we created earlier. So psconf bin, psconf module. Anyone using Plaster for any of their work? Okay. Rightio, so that's scaffolded my folder. So now I can run code and we can have a look what we've got. So the folder structure I use for my modules is I use a private and public folder. I also have that underneath. So here you can see I've got the VS Code folder where I was talking about those settings and those tasks that you may want to create. I have psconf, which is actually the module itself. I then have my pester tests and the private and public to match my folders that I use in my module. And then I have a whole series of other files that are used as part of the build process. So Git Ignore, the whole reason we're doing this is because we don't want DLLs and executables to end up in the repository. So we need to make sure that the Git Ignore is actually ignoring any folders where we might be putting that type of content so we don't accidentally load that up. We have a YAML file which is for our Azure DevOps build process. So you can define the whole build process in a YAML file now, which is a great feature. Build utilities is part of Invoke Build. At the moment, we don't actually have any custom functionality in here, so it's really there if you wanted to use some other functionality Invoke Build in the future. The packages.config, so this is an interesting one. This is actually used by NuGet to say what packages, what binary packages do I want to bring in. So when you're running the build, it'll look at this file and say, okay, I want to bring in that take.io network DLL file that we put up there. So I need to modify this and put in the correct name of the package. So that's the same name as what the package that we pushed up and the version number that we pushed it up with. So just save that file. The psconf.build is the main build file for Invoke Build. So the way Invoke Build works is you can have essentially sets of tests. Not sets of tests, it's sets of tasks that you want to run, and you can chain those tasks together. So for example here I've got task test, and it's actually chaining clean, install dependencies, run tests, confirm tests, pass together. I then have a task dot, and dot is the default build task in Invoke Build, and it actually chains test and publish NuGet together. So it then goes and runs test, which is all these ones, and also publishes to NuGet. So in this file, we've got some logic to handle getting the NuGet package from Azure DevOps and expanding that into our module. So we do a NuGet restore, and that's looking at that packages.config that we just updated. We make a directory called lib under our folder structure. So at the moment you can see there is no, in our module, there is no lib folder. And then we expand the contents from the NuGet package into the lib folder so that it's available for the module. There's a few other tasks in here. Clean is just getting rid of any mess that we've created from previous runs. The run tests, so we're running the pester tests. The other one that's a little bit interesting is publish NuGet. So what this is doing is it is incrementing the version number, and we're actually using build number, which is an environment variable within Azure DevOps. So it tracks, it's a unique number that gets incremented every time you run a build. So it's a way of us making sure that we have a unique build number on our module every time. Then we actually export the functions from our public folder because we want to update our manifest every time that we're doing a publish. So this is where people might be doing export member individually in your PSD1 file. This is updating PSD1 file automatically with any of my public functions. Now Ben actually had a great suggestion around, I'm just doing this by the moment in this script by iterating through the folder, and I look for the folder name, and that's going to match the public function name. But you can actually use the AST, the abstract syntax tree, to actually load those files and look for any functions. So the updated version of this module that's on GitHub, it actually has the AST stuff implemented. And then we're actually saving a new spec, which is used to create the NuGet package for our actual module. So with PowerShell get, you can go find module from the PowerShell gallery. You can do install module, and you can do publish module. But there was there's some limitations that on the versions of NuGet that it works with, and version 3 that the Azure DevOps is using for the NuGet repositories isn't supported properly. So that's why I actually create my own NuGet package rather than using publish module. There's been a lot of work happening in this space. So the PowerShell package manager and OneGet have just been updated. I think version 2 is the latest version. And they're trying to address some of these issues, but they're not all resolved at the moment. Okay, so that's our new spec file. And then we have some settings that's used by Invoke Build as well. So I'm going to copy, I've created a couple of simple functions that we're going to put into our module. So we'll copy those in. So we just got 2 public functions, and we should have a couple of tests here to match them. So new subnet, it is actually going to use the DLL that we get from the NuGet package. So you can see here, we're instantiating that .NET class from that DLL. So I also need to add, while I'm at this, to my module manifest, I need to add the DLL. Okay. Now the other thing you can do with VS Code, so this idea of tasks, VS Code has its own tasks engine sort of built into it. So you can specify I want to run a build, I want to run tests. I can define those tasks in this task.json. And that sort of matches up quite well with what we're using Invoke Build for. So in Invoke Build, I've got those particular tasks. So as part of my plaster scaffold, I build out these tasks so that I can access them from VS Code as well. So I can go task. So there's a couple of default ones. So I've got a test task, I've got a build task, or I can just go run task. So if I do run task, I'm actually seeing the tasks that are in my build. So I had analyze, clean, confirm, test, pass, publish, NuGet. They were the things that are in my Invoke Build. So when I run one of these, all it's going to do in the background is run Invoke Build with whatever setting I want. So let's run the tests. So the test is actually getting the dependencies. So it's going out to VSTS. It's pulling down that NuGet package that contains our binaries. It's expanding it. It's copying the files, the DLLs, into our lib folder for our module. And then it's going to kick off my pester tests. Okay, that looks good. So let's look what happened here. So I've got a lib folder that has my DLL in it. So that DLL is not being stored in my Git repository, but during my test task, because it installs the dependencies, it is now in the module. So when we push this up to VSTS, that same process, that same build process is going to happen. So we don't have the DLL in our PowerShell module. The build process runs, gets the DLL, puts it into the module, and then it'll publish to the repository. So what we're going to do, we're going to initialize this as a Git repository now. I'm going to stage all my files. I'm actually going to remove my build YAML file from my initial commit. I found with Azure DevOps, the first time if I do a push and I've already got my build YAML file there, Azure DevOps doesn't pick up the build. I then need to make a change and then push again. So the easy way to do is not push that file first and then push it second. So if we switch back to our Azure DevOps, I should be able to see my files here now. I need to push them up to Azure DevOps. Okay, let's refresh. So I've added that remote onto my Git repository, and I've pushed all my source files that I just staged up to Azure DevOps. There we go. So all our files are there, except for our YAML build. If I look at my build pipelines, there's no pipelines defined at the moment. So we'll go back to VS Code, and now we'll add our build. So push this up, and we should see Azure DevOps pick up this file in a moment and actually kick off a build. Okay, so we've got a build pipeline now. I can drill into this, and I should be able to see the steps. So there's a whole series of steps that it's running through. We'll have a look at the YAML file in a moment as well, but essentially it gets the Git repositories, it's doing a NuGet restore, we're running the Invoke Build, and when I'm doing the Invoke Build, we're updating the version of Pester and installing Invoke Build. Then we launch Invoke Build, we do a NuGet push of our artifacts of our module up into the PS-conf module, and then we publish our test results. So in the YAML file, what does that look like? It really looks pretty much identical, just in a text-based version. So I'm saying install tools, so it installs NuGet. It's doing a NuGet restore. I have to pass what the feed to restore from, so it's using ps-conf bin. The permissions, because I'm running this within Azure DevOps, it has permissions to those feeds automatically. So it does the authentication to the package management feed automatically. I'm then installing the NuGet package provider, so I'm bootstrapping that so that you don't get prompted when I try and install Invoke Build and Pester. So we're installing Invoke Build from the gallery, install Pester, and with Pester you have to use a couple of properties because Pester was baked into Windows 10. In order to get the update to work, you need to actually use force and skip publisher check, and that way you'll get the latest version of Pester. And then we're going to run our Invoke Build task, which is actually doing our build, and we're running the tasks install dependencies, test, and publish to NuGet. So when I ran it locally within VS Code, I ran the test, which didn't include publish to NuGet, so it just it did the restore and ran the Pester tests. And then we're going to do a NuGet push. So this is actually pushing our PowerShell module into our private repository that we created at the start. And then publishing the test results. Okay, let's see how our build's progressing. That looks good. Everything's completed. So if I look at my tests, so I've got some very basic tests in there, but I can see the statistics about my tests, which is very helpful. And then I can go and look at my artifact repositories. And if I look at my module, here's my PowerShell module. And you notice the build number, the version number, 10058, that will actually match up with the build number that happened during that process. So the other thing you get with this is you get versioning of those artifacts. So we're gonna update this module in a minute, and we'll see a new version appear here. But let's set up one PowerShell get on my local machine to go and retrieve that module that we've just created. So to do that, we need to register a new PS repository. So we're just going to call that psconf module, and our source location actually points to the location for the repository. And we're going to say it's a trusted repository. So this warning it's quite interesting. The way it works is trying to contact the feed, and it isn't able to authenticate to the feed. This is one of the bugs that I was talking about with the way that the package manager is currently working with version 3. That warning doesn't actually matter, but I need to open a new PowerShell session, and then I should be able to do find module against my new repository. So you notice I've actually passed a credential. As part of my profile, I've actually stored my personal access token for the repository and my username as an encrypted XML file. So I can see my module. And now we're going to do actually, who's used PS default parameters before? So what PS default parameters does, it allows you to specify some criteria for different functions or commandlets that you're running, and then you can put in default values for parameters on that execution. So for here I'm saying for any command that's *-module, so find module, install module, update module, it will pass into the credential parameter $cred, which is coming from my profile, and it will pass the repository as psconf module. So instead of instead of having to specify, like I did here, psconf module and cred, I don't need to specify those at all. I can just do install module. And the name of the module file, psconf. We're going to do scope as current user. And what we should see, so this is my current user modules folder. There we go. So we've just installed our module that we've built from Azure DevOps. If I look in there, I can see I've got my lib folder, and it has my DLL that I want to use. So now I can invoke a command. So I'll do new subnet. This command actually uses that DLL to do some network calculations. Okay, I've got another command that we published, which was the get psconf. If we have a look at that command, so it produced no output. And if we look at what it was actually doing, it did a get item on the C drive and it piped it out to null, so you're not expecting anything. So let's update this file. So the beauty of having the build process set up now is that when we do want to make changes, it's very easy to do. So I've made a change to this file. I can see I haven't committed it yet. I can run my tests locally. I haven't actually updated the test, but in normal operation, you'd update your test, make sure everything still looked okay. Let's just try that again. Okay, so our tests run fine locally. So then we do our normal process. Let's commit this file. So the build hasn't kicked off yet because I haven't pushed that file, but as soon as I push the file up to Azure DevOps, we will see another build kick off. Okay, our updated file, and we can watch that build process happen now. So that's going to take a minute or two. Any questions while that's running? So one of the main drivers for not putting the binaries into your repository is when you want to do the type of CI/CD development, if your repository gets too bloated, all your activities start to slow down, because every time your build agent kicks off, it does a clone of the repository. If you're using hosted agents in Azure DevOps, it's got to bring down that repository each time. So once you start getting sort of up in the gigs in size of your repository, that can cause you a few issues. How many people are running a private PowerShell gallery? Yep. What software are you using for your private galleries? JFrog, Artifactory. Yep.
So we're doing this.
Yep.
And one interesting thing that I found is that for our operations team who use the modules that we're creating, they need to have contributor access to the repository that hosts the package manager. Otherwise, they can't authenticate into the.
Because one of the things I found also was if I didn't use a personal access token,
Yeah.
then I'd have issues accessing that repository.
Exactly, yeah.
And I think that was a limitation. That's just a limitation on how Azure DevOps works.
Your expectations
Yeah, that is interesting because you can, when you're creating the repositories, you can set whether they're going to be public or private as well.
Yeah.
So if you had a use case where you could make it public, then I would expect that you wouldn't need to do that.
Yeah, I wonder whether that's the solution. Like, we might have to look into that. But yeah, that
Depending on what type of content.
that I had
Yeah.
caused a lot of headaches.
So our build's completed successfully. So let's go and have a look at our module repository. And if I look at versions, so I've got a new version that was just published a minute ago, and I've got my old version. So now what we want to do is we want to actually update that module. So if I do update module, psconf, so it's going back to Azure DevOps, back to that repository. It should see the new version. What we should see in the folder. Okay, that's done. So I now have a new version in my modules folder, and that's going to have the new file in there. So now if I do an import module, and I have to do force to make it reload, and if I run get psconf, PowerShell rocks. So that's now we're seeing what your normal development lifecycle is going to be like as you want to maintain your modules going forward. So the main challenges I found were really the fact that the package manager and OneGet have issues with the version 3 of NuGet API. That made some complications in terms of my build process. Otherwise, you could simply have used publish module rather than having to create a NuGet spec file, which would be a lot simpler. So the other things I found were, so when we look at the folder structure here, some people are now starting to take the public folders. So I use private and public because it makes it easier to test my functions. But some people are actually in the build process. They're then combining that all into the PSM1 file. So all your public, all your scripts would actually then live within your one PSM file, and you can do that as part of your build process. The other thing you can do with your build process is if you want to be pushing to the PowerShell gallery, you could just add another task there that was actually pushing the results to the PowerShell gallery. You can also have an idea of a release pipeline as well. So at the moment, we're running a build, and it's pushing our artifact into our PowerShell gallery. You could have that essentially stage that artifact, and then you could have a release pipeline, and that release pipeline could release into a test gallery and then into a production gallery. So there's definitely lots of ways that you could expand that as well. So I'll just show you in that task.json again. So when these tasks that appear in VS Code are literally defined in here. So you can add any other type of task that you may want to do as part of your development process as well in here. Okay, that's the major part of the demo. If you're not using Azure DevOps, I can't recommend more. I recommend that you definitely set up an account and try it. It's free for 5 users. The package management feature for the artifacts, it's free for 5 users as well. So you can get a 30-day free trial license, but if you've only got less than 5 people in your team, you're not going to need those licenses anyway. When you want to set up your access token, it's just under the security, and then you can set the scope of where your token can see. So if I go new token, this has changed very recently. Here we go, show all scopes. So there'll be a scope for package management. Packaging. So you just need, depending whether you're doing just that read task, For the read, when I'm doing install module and find module, I just need read, and when I'm doing the publish, I need the read and write. Any questions? Okay. Yep.
So you're obviously doing tests per commit or pull request.
Yes.
Can you do your artifact pipeline on like per tag?
Yeah, you probably can, because within Azure DevOps, when I do my build process,
Yeah, so the automation I'm looking at is you tag something in the upstream repo, it automatically creates a build, shoves it onto your test gallery and says, hey, does it?
yes. Yeah, because it's got so many conditional access, conditional objects on those build tasks. So you can have, if we look at the, so the triggers, this is what provides the continuous integration. So when I did that commit, this trigger says, I see a change, I see a commit, kick off a build process. We're actually specifying in YAML to do that continuous integration, but you can do it in here as well. And so then you can be setting branch filters. So you can be building off particular branches. So for the your ups,
Tags will be passed because they're a reference.
okay, yep,
/ref/tags.
okay. So then you could put those features in there. All right, yeah. So just to summarize what we've done. So we set up a brand new project in Azure DevOps. We initialized our repository as we created our code. We created our package manager feeds. I'd already created a personal access token, and that's what I have in my profile. We registered our NuGet feed. We then pushed our binary package up to that NuGet feed that we registered. We created our local module. We scaffolded the project using Plaster. We added our functions and our pester tests in. We updated our PSM1 to load our DLL. We updated the packages.config with our binary dependency, and then we ran that test locally and did the restore of our binary components. The build process, having the build in the YAML file makes it really good from the perspective that your build process is then version controlled with your code base. And that's one of the real advantages of it. I think there is some talk that the release processes will be able to do the same thing in the future. It's not there at the moment, but you could then have your release process as a JSON file and have some automation that pushes that JSON file in to create your release pipeline. We saw the builds happen through Azure DevOps, and then the real cream of the whole process was being able to find those modules from our local machine and then do that update and see that our code has been gone through a build process and actually come down to our local machine. So I've got a number of links to various resources that I used when I was going through the process of creating this. So I'll make that available after the conference. There was also a PowerShell conference book that was written after the summit in America in April this year. So I contributed a chapter around this as well for that book. Any other questions before we finish up? So I need a bit of continuous integration and some unit testing. Microsoft loves geeks. So, thank you.